A hot plate of an electric oven connected to a 220-volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in three cases? So we have to find the current in three cases, that is separately, in series, and in parallel. So first, the voltage given is V is equal to 220 volt, and two resistors have the resistance of value 24 ohm. So this A and B resistor can be used separately in series and in parallel. So let's take the first case separately from Ohm's law. V is equal to IR. I is equal to V by R. This is equal to 220 divided by 24. So I is equal to 9.17 amps. So next case is series. These A and B resistors were connected in series. So in series, total resistance or series resistance is equal to R1 plus R2, which is equal to 24 ohm plus 24 ohm equal to 48 ohm. So R series is 48 ohm. Now substitute in Ohm's law, I is equal to V by R series. This is equal to 220 divided by 48 is equal to 4.58 amps. So here I is equal to 4.58 amps. Then third case is parallel. So parallel case, these are equal resistors, coils. Two resistance coils have A and B, each of 24 ohm resistance, which means they have equal value of resistors. So R parallel is equal to R by number of resistors is 2. So R parallel is equal to, what is the R value? That is 24 divided by 2. Is equal to 12 ohm. So R parallel is equal to 12 ohm. So from Ohm's law, I is equal to V by R parallel, which is equal to 220 divided by 12 is equal to 18.3 amps. So I is equal to 18.3 amps in parallel combination. So in these three cases, you can see that at first here separately R is equal to 24 ohm and current is 9.17. And in series case, R is 48 ohm and current is 4.58. And in parallel case, R is 12 ohm and current is 18.3 amps. So if you compare this, the series have low current, that is 4.58 amp, because the resistance is increased here. But in parallel, the current is higher because the resistance is decreased here, that is 12 ohm. Thank you. Show how you would connect three resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm and 4 ohm. So we have to find the combination of these three resistors to get this value, two values, 9 ohm and 4 ohm. So first for 9 ohm, let's see the R1 and R2 were connected in parallel and R3 in series. So first solve all R1 and R2. So to find the R parallel, that is parallel resistance, 1 by R is equal to 1 by R1 plus 1 by R2. But here these are identical resistors, so we can simply calculate is R parallel is equal to R by N. So R is the value of resistance, that is 6 ohm, and then N is the number of resistors connected. So two resistors were connected, R1 and R2, so N is 2. So R parallel is equal to 3 ohm. Now R3 is connected in series. So we have to find the total resistance, that is R is equal to, this is the total resistance value of this parallel combination, and R3 is connected in series. So we have to add this resistance. So R parallel plus R3, which is equal to, R parallel is 3 ohm and R3 is 6 ohm. Is equal to 9 ohm. So to get the value of resistance as 9 ohm, we have to connect two resistors in parallel and one resistor in series. Then second case is for 4 ohm resistance. For 4 ohm resistance, let's reverse it. That is, connect R1 and R2 in series. R1 and R2 in series and R3 in parallel. So to find the total resistance of series combination, we have to add that. So Rs is equal to R1 plus R2. So the value of R1 and R2 is 6 ohm. So 6 ohm plus 6 ohm is equal to 12 ohm. So Rs is equal to 12 ohm. Now this is connected in parallel with R3, which means the total resistance in parallel combination is, there is 1 by R parallel is equal to 1 by Rs plus 1 by R3, which is equal to 1 by Rs is 12 plus R3 is 6. So 6 plus 12 divided by 72, which is equal to 18 by 72. So 1 by R parallel is equal to, cancel this, 6 3s are 18, right? 3 is 6, 8 3 is 24, 1 2 is 2, 4 2 is 8, so 1 by 4. Then R parallel is equal to 4 ohm. So to get the value of resistance 4 ohm, we have to connect two resistors in series and one resistor in parallel.